Hey guys, this is part 2 of our trig functions video, and like I said, this is really lengthy, so I'll hopefully get it done in a second part, but there's a possibility we may have a part 3 in this particular lesson. Alright, so where we left off with part 1, we were talking about how this number in front of the sine theta, this 2, actually changes our amplitude. This is our amplitude. Remember, amplitude is just the height of the waves. So a regular sine function has a height or an amplitude of 1. By changing the amplitude, we've just bumped it up now to 2. Our zeros are still the same. The only thing that we've done is change the height of those waves, if you will, just the amplitude of our function. If the coefficient were -2, the amplitude would still be 2, but because of this negative, it would reflect our graph across the x-axis. So let's take a look at that. So here's what it looks like with an amplitude of +2 with a -2. Our graph is just reflected across the x-axis. So our zeros are still the same here. Let's go ahead and draw this out. Zeros are still the same, but our sine function would look like this. So still an amplitude of 2, but that negative reflects it across the x-axis. A horizontal translation of a trig function is called a phase shift. Now, if you remember back when we were doing translations, that horizontal translation, that was what was inside the parentheses. Right? It was that x minus h plus k is what we had earlier. So this horizontal translation, that's going to be inside now instead of with our x, but with our theta. In trig functions, it's called a phase shift. So it has a special name. So let's take a look at this. We have our cosine function, so f of x equals cosine theta. But notice in the parentheses with our theta, we've got this phase shift here. Okay, x minus h. In this case, our h is pi. So our phase shift is pi units to the right. Remember, this negative sign is just a minus sign. It's not negative pi. We're only looking at this unit right here. So it's pi units to the right. Let's take a look at what that looks like on a graph. Right? Knowing our cosine function, if you remember, our cosine function is typically at 0, it's up here at 1, and at pi over 2, it's at 0. Right? So our cosine function typically looks like this, going this direction. Again, our zeros are still the same. But all we've done is shift that pi units to the right. So now, instead of having cosine equals 1 at 0 pi, we have cosine equals 1 at pi. Right, so we've just taken that whole function. If you could pick up that blue line and move it down pi units to the right, that is what we have done. So everything just moves pi units to the right. All right, take a look at this function, y equals sine 2 theta. Now, the blue line on this picture represents the original sine function. You can see our amplitude here is 1, and our zeros are right here at 0, and at pi, and at 2 pi. The red function represents sine of 2 theta. Now, this is not an amplitude change because our amplitude would be here in front of sine. So what does it look like that 2 theta did? It looked like it, if I had to describe it in non-mathematical terms, it squished that function together, right? It shortened our waves. And so now, instead of our zeros being at 0, pi, and 2 pi, we now have zeros at 0, pi over 2, pi, 3 pi over 2, and 2 pi. It's squished that function together or shortened the length of our period. Where before, our period was 2 pi. Remember, a period is where it repeats, so it repeated every 2 pi. Now we have our wave, or our period, as just pi. So putting that 2 in front of the theta affected our period. The coefficient of 2 changes the period, and here's our definition for that. The period of a sine or cosine function will be 2 pi, which is what we learned in 3.4 with periodic functions, divided by the absolute value of n, where n is the coefficient of theta in the equation. So we know here that the period of our sine and cosine function is 2 pi. That's a given. We know that for a fact. Tangent is pi, but sine and cosine are 2 pi. And our n, that coefficient there in front of the theta, is 2, so we're going to divide that by the absolute value of 2. And when we do that, we find out that our new period, as represented by this function, is now just pi, which is what we see represented by this red function. So a formal definition is 2 pi divided by the absolute value of n, where n is the coefficient of theta in the equation. So here is the general form of the sine function y, or f of x, equals a sine times n theta minus b. All right, let's talk about what these letters represent again. A is our amplitude. N is the coefficient in front of theta that's going to affect our period. And B is that horizontal shift, which in sine and cosine functions we call phase shift. Now, I don't have that written on this slide, but in your notes, you need to know that that is what those represent. A is amplitude, B is phase shift, or horizontal shift, and n is that coefficient in front of theta that's going to affect our period. So to determine our phase shift, it will be b divided by n. Now, when we did our phase shift earlier, let's back up a few slides to where we did our phase shift. We took b divided by n. In this case, our n is 1. So our phase shift was b divided by n, pi divided by 1, which was just pi. But we're not always going to have a 1 in front of that theta. So we need to determine the phase shift even when our coefficient isn't 1. All right, let's come on back to an example here. We're going to graph y equals negative 3 sine of 1/3 theta divided by pi over 2. Now you see that there's already lots of math here, and I'll refer to these examples in just a second. Let's determine, first of all, what our general sine function looks like. You should know that your sine function starts here at 0, and it goes up typically to 1 and down to negative 1. So it's got this general look if we had to sketch it. So let's get that image in our head. Now that's with an amplitude of 1, but according to this, our amplitude is 3. Negative 3, so it's going to be reflected over the x-axis, but still an amplitude of 3. So now our function, instead of going up to 1 and negative 1, is going to go up to 3 and down to negative 3. All right, to determine our horizontal shift or our phase shift, going back to our previous slide, we need to take our b and divide it by our n. So here you see that math, pi over 2 divided by 1/3, which is the same as dividing by a fraction is multiplying by the reciprocal. So pi over 2 times 3 over 1 gives us 3 pi over 2. So our phase shift will be 3 pi over 2. So instead of our sine function being 0 at 0 pi, we're going to start our sine function a little bit to the right at 3 pi over 2. And then to determine our period, we're going to take 2 pi divided by n. And because this is a sine function and our period is 2 pi, we've got 2 pi divided by our n, which is 1/3. Again, multiply by the reciprocal here. 2 pi times 3 equals 6 pi. So our period, or our function, will repeat every 6 pi instead of every 2 pi. Let's take a look at what that looks like. Again, I'm going to kind of sketch our sine function. Our original sine function starts here at 0. And it, let's see, 1 pi over 2, 2 pi over 2. There's a 0 and 4 pi over 2. And we go up to 1 and down to negative 1. All right, so the purple line represents just that first part of the original sine function, and the blue line represents all the changes that we have made to it. We've got an amplitude of 3. We have a horizontal shift of 3 pi over 2. Notice instead of starting right here at 0, we're starting at 3 pi over 2. And our period repeats every 6 pi. Every 6 pi. It's got that marked off in green here, every 6 pi. Now let's talk really quickly about this negative amplitude. That negative number, remember, reflects it over the x-axis. So in our original sine function, we started at our origin point here, and we went up to 1. So instead of going here and going up to 3, because that was a negative 3, we're starting at our new point, that 3 pi over 2, and going down 3. So that negative 3 is that reflection there. So we had to take all of these bits of pieces of information in order to graph this new sine function. All right, use your calculator to graph y equals tan x. Just a reminder that tangent is sine over cosine. At places where cosine of x equals 0, see if you remember where that is on the unit circle. Hopefully you said at pi over 2 and 3 pi over 2. So at those places, tangent is undefined, because anything divided by 0 is that undefined number. So when we graph that, it should look like this. So you can see at pi over 2, 3 pi over 2, 5 pi over 2, etc., 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 we have these dotted lines. And these dotted lines represent vertical asymptotes. Those are those places where a function cannot cross. They're not part of the graph, but they show us that no values exist there. It's undefined. Okay, and the rest of our function looks like kind of like these squiggles. Now take a look at it. Can you tell me if tangent is even or odd? We'll get to that in just a second. Can you tell me the domain? Can you tell me the range? See if you can identify those on your own before we get to that, whether it's even or odd, the domain, and the range. What about the period? Do you remember what the period is for a tangent function? All right, let's see what information we can get from this graph. Our period is pi. It repeats every pi. Let's go back and look here. Okay. Each of these two units represents pi, so it repeats every pi. Okay, what about our function? You should have identified it as odd, okay, because it is not reflective across the y-axis. It is reflective across the origin. Our domain is all real numbers except for it cannot equal pi over 2. Pi over 2 is when cosine is 0, or anything, any other angles that would have pi over 2 and then have pi over 2 plus 1 pi, or pi over 2 plus 2 pi, pi over 2 plus 3 pi, or 4 pi. Each of those values is when cosine is equal to 0, and so it's undefined. So our domain is all real numbers except for where cosine is undefined, and the formula for where cosine is undefined is this. Our range is all real numbers. Those tangent graphs will keep on going down and keep on going up, and our ranges are y values. The general form for the tangent function is this: y equals a tan n theta minus b. The graph becomes steeper as our amplitude increases. The graph will become steeper. If you want to play around with that in your graphing calculator and see how that changes, that will be a really good visual. And our graph translates b over n units horizontally. We call that a phase shift with sine and cosine. Here we're just going to call it that horizontal translation. And our period is pi divided by n. Remember, sine and cosine, their period is 2 pi. So to find the period of our new function, we had to take 2 pi divided by n. But the period for a tangent function is just pi, so we're going to take pi divided by n. All right, guys, we fit this in 2 videos, so here's a quick review of what we did. We defined the trig functions and reviewed trig ratios. We determined the period, the amplitude, phase shift, the domain, and the range for sine, cosine, and tangent trig functions, and we worked to graph them. We will obviously continue to practice this in class a little bit more. If you have any questions, please write those down, and I'll see you guys in class.